In this video, we're going to take data from a remote solution here and use a LoRa radio to transmit it to a computer and then get the data straight into Excel using Data Streamer. Let's get going. Okay, so what do we have here? We have a CR03, that's a radio for ITU region 2. It is the Americas, North and South America. The same we have here. If you are in EMEA, that means Europe, Middle East, Africa, Russia, then you should go for the CR02, which is a radio for that region. We have a IPO1. It's a programmer that can program the CR03, so you use it both to program this one and this one. It's also supply power, and it's also supply serial communication, so it reads the serial communication from the CR03 into the computer. On the other side here, and both the CR03, by the way, have an Arduino core, so this little chip there is the same as an Arduino Uno chip, so it's an AT-MEGA328P. The SW1 we have sitting here is a weather sensor. It measures temperature, humidity, and barometric pressure. The OCO3 is a solid-state relay, so I use it to turn this fan on and off, depending on the command I'm getting from my Excel spreadsheet. And the PG is a generic power supply where I can put any kind of power from 6 volt like I have here, up to like 12 volts like a car battery, up to 24 volts like 2 car batteries, whatever solution you have. The nice thing about this one here is that it doesn't matter where you put plus and minus into this connection here, because it will turn it around so it's the right way around for the circuit. And this is just a relay, so here it doesn't matter what you put into which side, on this side also. So the power goes in here, and then I have some power going in via the relay to the fan also. So all this is running itself, and I can move it to some other location. For the purpose of this video here, I just included it so you can see it in this picture here. So let's go to the computer screen. Here I have something I call DS Sensor End. In the version I uploaded to GitHub, and there's a link in the comment. I'm going to put a link here also. You can go in and find this sensor end. I call it the sender.ino when I upload it here, because it actually sends the data from the SW1. And the other code I have here, or I call it an Excel end, because that's one plugged into Excel, that's receiver. Now, receiver and sender is a little misleading because they both send and receive data. But let's look at it. So the sensor end here, I have used a library, and in the description in GitHub, I have put in what library you have to use. So these libraries here, LoRa, Xcore, XSW1, XOCO3, there's a link to where you find those libraries in the GitHub. So you install those, you download the INO file here and compile it. It runs the 915 radio, which is a CR03. So 915 is a frequency. If you have a CR02, you have to say 868 instead of 915. It's also described on a GitHub page. This is actually the only thing you have to change. After that, you can simply just compile it and upload it. But I'm just quickly going through the code. So here it sends data. So this is the main loop I have on the screen now. So if you look at this part here, there's a time interval here which is set to 500 milliseconds. You can change that obviously. I go in and pull the data from SW1. Then I construct a comma-separated line here with the 3 Ds. So I kind of like construct a comma-separated insert here with the 3 different values, and I send that message using this send message. Then I check if there's any packets received, and then I deal with those packets. The send message just looks like this. I took it from an example. So when you install this library, there's a lot of LoRa examples you can use. The one I used here was called duplex, since it both sends and transmits. On receive, it receives data, and what I simply do is that I'm waiting for this incoming text that comes in here. I have a serial print, so if I connect it to another IP01, I can actually see on my computer how the data looks like. So it's good for debugging. If you think you're going to do more development and debug, I suggest you get another IP01 so you can have both your CRO3s connected to your computer at the same time. So if you are looking at the shopping list and the GitHub page, then add yourself another IP01. You can also take an IP02. It can do the same thing. And then I actually react on this incoming. So if I get like a 1, I turn on the relay. And if I get anything else than a 1, like a 0 or like a 2 or like on or off or whatever, I write a text, then I just set it to low. So a 1 in the field in Excel gives me a relay turning on. Let's look at the code on the other side. So over here on the Excel end, similar situation, you have to change the 915 if you are changing radio or using another radio. The main loop here looks more or less the same. In this case here, I check if I get data from Excel, so that comes over the serial port. If I get data, I simply take this data here and I write it and send a message with the data. So one of the things you just have to be concerned about is that data that comes over the serial port, when you kind of write them into a character array, just make sure you have set it to 0 first so you don't have any noise in the character array. So that's what's happening here. Send message, similar thing. When we receive data, then we take the data and we generate a comma-separated output. So we simply take the incoming message ID, the length, the string that comes with now comma-separated already. So there is like not only the 5 fields you see here, but there's 2 more fields. There's 3 fields in total coming over, replacing that 1 field. So there's 7 fields coming over in this thing here. And then we have the radio signal strings indicator, and we have the signal noise ratio as coming from the radio, which I'm also sending over. So you, as it says in a GitHub page, you take the first one, you use the IP01, you program the one CR3, you take the CR3 out, you put other CR3 into the IP01, and you program that, and then you have programmed the 2 devices. After that, you build your circuits, similar to I have here, connect antenna, and let's see how that looks in Excel. So if I go to Excel, so I'm going to start Excel up here. And then I'm going to open a blank book. There's a link in a GitHub page of how to get the data streamer activated. There's also another video I made where you can see how to get the data streamer activated. So I'm not including here. It's not a big process, but you can see that in another video. So up here, there's something called data streamer. If you have your radio plugged in and say connect the device, you can see here it says there's a COM port here with a connected device. And what it does now is it creates a number of seeds. It puts all these tables up so it's ready for you to play. And then you simply say start data, and then the data comes in. And I have like half a second in delay. When I play around with it, I normally just take the delay out so it fills up very fast. But here's a half a second. So you can see here, the first is a time. So I'm sitting in Europe, and we're using a 24-hour time here. So 17:52 means it's 8 minutes to 6 in the evening. The next is the message ID. So you can see here comes the message ID over. It counts around 255 and then it starts over. Then you have the message length, and of course the length is more or less the same because we have like 2 decimals for temperature, 2 for humidity, and 4 for for pressure. So that's the next one here. So 30 degrees where I'm sitting now. The humidity is around 40-41, and the pressure is 1007 hectopascal or millibar. And then we have the RSSI minus 10, and that's of course because the radio is sitting very, very close to each other. So if I take the radio solution here and move it kind of a little bit further away, you can see then the RSSI goes up and went up to 55, dropped down to 46 again. And then you can see the last channel, channel 7, is then the signal noise relation. So all very, very fine. If I bring my circuit back into the view here of the camera, then I'm going to show how I turn the fan on. So down here it says data in. If you go to data out, there is a channel here. Now the way it works is that it simply sends to me all these different channels with a comma in between. So there's a little LED here and of course a big fan here. And if I here on data out go in and put a 1 into this field here, you can see the fan turn on and there's a little green LED here that turn on. So if I go back and say 0, then of course the fan turns off and the light turns off. Now if I want to use that to automatically turn the fan on when the temperature gets too high, then I go in and write a formula here. So I say equal if, and then I'm going to data in and I'm looking at the temperature coming in here and say 30. And then I say if that's bigger than 30. So now I'm asking the current data coming in there. If that's bigger than 30, then I want to turn the fan on. Sorry, you have to use commas. I want to turn the fan on, otherwise turn it off. Okay, so we do that. And now it says 0 there. Okay, so we go to data in and you can see it says 30. So now I'm going to put my finger on the temperature. See if we can raise the temperature on the device here. There we go. So the temperature went up to 33 degrees and the fan turned on. So now you can see the temperature dropped to 31. And if it manages to drop all the way to below 31, then the fan will turn off again. You can choose to do this project with any other sensor. You can use light sensors. We have an SM19, it's an infrared temperature sensor. You can use light sensors. You can use the OCR3 to turn on and off air condition off. Or maybe you have a window a door that can open automatically based on, for example, CO2 in the air, like using the SG33. So a lot of different sensors. The idea here is just to show how you can experiment with using LoRa radio, which can be used in a very, very, very long distance. So setting up this thing here, you can have it much, much, much further than you could with any Bluetooth or Wi-Fi. So if you're out in the farmland, you can have this thing here kilometers or miles away from your home. Just make sure you have good antenna connections. These antennas should be sticking straight up if you're using those kind of antennas. But we have been putting this radio, the CR01, which is the 433 megahertz, we're putting on a balloon and communicated between two radios like that for over 200 miles or 300 kilometers distance. So the radios, if there's a good free site, can communicate far. The other nice thing about the LoRa radio is that it's a low power radio. So the circuit here is very low power. Obviously, depending on how often you report data forward and backwards, and you have to send data, makes it a little bit more costly. But for a project like this in here, where we want to see the result all the time, we obviously want to have a higher frequency in the data. If you have any issues, I urge you to raise the issues in the GitHub issue page, and I will look at it from time to time and see if I can explain or update or make the project easier or better. Hope you enjoy. Thank you very much.